Alright, now that I can do this, we're going to do the Joe Pye method of high-speed threading. So I got the lathe set up here with an upside-down threading tool. I'm going to run it in reverse. I'm going to thread this baby at 470 RPM just to say that we can do it. Here we go, watch this. Yeah, baby! Okay, so I made a little bit of a change to this thing. Take it off and show you here. Okay, so what I ended up doing is I ended up cutting a little shallow keyway here and putting a screw in one of the holes that was already drilled in my spindle, so it keeps it from rotating and makes it easy to put in. You know, you can just screw the nut on. And the other thing I did is I had a bunch of these dividing plates left over from when I converted my rotary table to an indexer with that stepper motor, and I didn't need these things anymore. So I've been, holding on to them, wondering what I can do with them. What I ended up doing was turning a little adapter bushing, left-handed thread, same basic thing as this, except it holds the wheels on here. And then this can screw on. Okay, so here's the setup. These discs here are 5.1 inches in diameter. So the radius is 2.550. So what I did is I placed this block 2.550 inches from the center of this rotary table. So what's going to happen now is this cutter is going to sweep an arc in here and cut away the clearance we need to get this in there. So I have a line for depth. It's not critical. I just got to get some clearance. And I've run this baby around. Verified that it's going to cut where I want it to cut. I have a little line scribed on there too. So we're going to start cutting here. Here we're touching. Back it out of there. And we'll go down 25 thou. And we'll start cutting. Now I've just got this rotary table in jog mode here. Put on another 25. Okay, it's the final cut, as one of my viewers pointed out. So yeah, you might notice that something has changed here. I decided to go all the way through it, so I jacked it up on a parallel. So we got through this pretty quick. I ended up taking 100 thousandths cuts off. Alright, should be it. So we'll take it off here and see how it fits. Okay, we're getting set up to drill a couple holes here. We're just gonna drill these 1/4 inch for 1/4 20 clearance. Alright, I'll get the other piece in here and I'll use a transfer punch to transfer these holes to the other thing, and then we'll drill those and thread them. Looks good. Okay, we got this number 7 drill in here. We're gonna come back to our 0. I've already spotted these holes. Alright, let's get some good juice going here. let's tap these. Alright. Alright, we get this thing finished up, and this is where you can just move it to whatever row you want, and you tighten it up. And now, however many holes you want, lock in there. Okay, so the mighty Wrong Fu has needed some adjustment, and I'm going to show you how to adjust the X-axis table backlash, which is what I had to do. So here's all the pieces you got to take off: the bearing block, this thing with the roll pin in it, and then the handle. So I've already taken it apart, and I'm going to see if I can show you what you got to adjust. See that Allen screw right there in the center? That hex head screw right there. That is the one that goes between the two split, you know, the split in the nut, in the table nut. So you gotta get yourself a real long, where did I put that thing? It's 4 millimeters, and this will reach in there and get it. But you gotta take off the bearing block to get to it, and then you gotta. What I did is I slid my hydraulic thing under it, and I'm supporting it under one of the ways, because you know the table's cranked over pretty good. I don't want the whole mill machine to fall over. So I'm gonna set the camera up and just let you watch me put this thing back together. Okay, so like I said, I've already gone in there and tweaked that little screw, and the deal is that it was essentially loose. So anyways, I'm going to throw this bearing thing back on here. I would grease it, but I don't think it needs it. Now, there were some burrs. Actually, there still are some burrs on this shaft, which made it real hard for the bearings to come off. Alright, that should be sufficient. Get this thing back on without too much effort. Now, I will tell you that this race has to go in with the curved side facing in. Okay, and the other thing you got to do is, before you do all of this stuff, is crank the table back. And can't crank the table because there's no thrust bearing in there. Okay, I think that'll make it. Yep. Okay, so that's the inner thrust bearing there. And this is a 6mm bolt here. Okay, there we go. So I'm not going to really sock up on these screws just in case there's a little bind because of the table being, you know, laying on that hydraulic thing over there. So the next thing you got to do is put the outer bearing race in. Okay, and that goes in here like that. And then the race itself, that was the ball thing, the cage. Okay. And then there's a collar. Oop, two-piece collar. Goes on. And I'm going to drive this roll pin all the way out. So you can see in there to line it up. Okay, and this goes on like this. There's the hole right there. There, I got it. Alright, I'm just gonna tap that in for now, and this way. Let's see if we fix this. Oh yeah, it's much better than it was. Alright, well today we have something interesting here that I'm really not sure what it is. I went dumpster diving again, and I got a couple of these chucks which I'll show you. I'll bring one up here. They're kind of heavy. I'm going to throw it in the vise and I'm going to take it apart. Alright, well there's the gold in this haul. I took this plate off of here, which is a nice hunk of steel in itself, and there's some really nice bearings in there. So I'm going to press those out of there and maybe salvage this shaft as well. The rest of it isn't anything special, but yeah, we get some nice bearings, nice shafts. Alright, see you in a few minutes. Oh man, she wants more. Alright, this time for sure. baby. Alright, now we can get these bearings out of here. Alright, and there we are. Two really nice bearings. These are VBF made in Russia. 6208. So I got two more coming out of that thing. Look, man, no wires. Okay, so basically what happens here is the wires run down through here, and I drilled a tiny little hole through the center of this tool post, and then they come out the back and go down and under so they can't get tangled up in anything. And I also added another link in here, so now you look right down the bore. Alright, so I have to make a little eccentric piece here, and I'm going to show you how to set this up in the chuck. So this piece I have in my hand is a 1-inch diameter piece of stainless, and what I want to do is turn a spigot, I guess you'd call it, so that it's of 550 thousandths diameter, so that it's tangent to the edge of the part. So here's a little picture, this one, and what I did is I took the radius and I subtracted the 550, and I came up with the center of the little spigot is going to be 275 in from the edge of the piece. So what I did is I took my calipers and I set them, and I just went around and drew a rough circle here. So the center of this spigot will be somewhere on this circle. It doesn't matter where. So what I'm going to do is center punch this thing. Let me get a whacker here. Alright, so I got this center punch mark right there. Now I'm going to put this in the forejaw with a wiggler, and we're going to dial it in. Okay, so the first thing I'm going to do here, if I don't hit the camera, is find the chuck key. Here it is. Alright, so what I'm going to do is align my punch mark with one of the jaws to make it easy. And I'm going to snug up just lightly the other two jaws. Okay, so I can clearly see that this has to move down. So what I'll do, loosen this one up. Tighten this one. Okay. Okay, we're almost there. Okay, so that's pretty close to the punch mark. The next thing you do, I'm going to show you, I don't need to really do it for this job, but I'm going to show you how to put a wiggler in here and get it really dialed in. Hang on. Okay, so this is a wiggler, and basically what it is like a shaft here with a flexible ball joint in it, and you get this pointer here. So, you know, typically you'd use this in the mill to center under something, but I'm going to show you how to use it in the tailstock to center up on a punch mark. Okay, so what I've done is I've chucked up the wiggler in the tailstock chuck, and I've put the pointer in my little pock mark here, and I set up the indicator to be like looking right at this wiggler. And you can't really go by the thousandths here. You can't say like, oh, this thing's off by like 40 thousandths, because it depends on where you put the indicator on this. You know, if you put it down there, you're not going to get any motion, hardly at all. And if you put it up, you know, if you were able to put it right at the point, then you could truly read what the offset was. But, you know, in the middle here somewhere, it's, you know, it's a ratio, so you can basically just center it. And it's the same op that you do with you know, your typical standard 4-jaw, where you tighten the highs and loosen the lows. So there's a low right there. There's my high. That's not nearly enough. Alright, and there you go. I'm within a thou, or, you know, I'm pretty close to where that center point is. You know, if I was going to screw around with it some more, I could get it to read 0, and then I know I'd be right on it. But that's good enough for this thing, so let's start turning here. Hang on. Okay, so the length of the spigot has to be 330. So what I did is, you know, I moved this in, touched off on the face, then moved over 330 and stuck a dial indicator on the waist so I know when to stop. Be turning this at 400 RPM. So we'll just touch off on the top here. Face with oil. You don't want to break the insert, so you want to come in really slow here until you just touch it. Okay, I'm touching it right now, so I'm going to set a 0 on the dial. I'm going to put on, say, 20 thou cut. Okay. haven't decided, you know, I don't use this 4-jaw chuck too much, so I'm debating on whether I should install a washer so I can, you know, lock it to the spindle and run it in reverse. It's pretty easy to do. I mean, you know, there's plenty of space in there to stick it in, so might eventually do that just for yucks. Taking light cuts here, 20 thou. When this gets round and starts turning into a continuous cut, then we can, you know, obviously take heavier cuts. But you know, when you're turning an interrupted eccentric like this, you know, there's a real good chance that if you're not careful, you break the insert. So we're coming up, this will be 100 thou right here. Yep. Alright, we'll just keep going on this, and I'll bring you back when it gets round. Because the next thing we got to do is drill a hole through the center of that for a 5/16 bolt. Alright, we get this turned down to the appropriate diameter. And as you can see, that is tangent to the edge of the original blank there. So what we'll do now is we're going to drill a 5/16 hole through this. Look and see here how deep to go. Looks like about 1 1/4. Alright, there's 1 1/4. That was a 1/4 inch bit. I'm going to put a 5/16 in here and do the same thing. See, Chris, it's almost a new brush. Okay, we'll turn it over and do the same thing. Okay, so there's my try at getting the cable up here. I didn't really want to drill any holes in anything, so you know, this part moves, so I am going to have like a little wire loop here. But this here is high temperature wire, so I'm not really worried about the short little exposure here. This is that's going to go to the power supply. So the piece is done. All I have to do is wire it up, which I will do later. Well, so ends another episode of Doodads. I hope you enjoyed watching me hacking a whack in my shop, make some stuff, and thanks very much to all my subscribers. I really appreciate the support, and we'll be back soon with another one. So take care and stay safe in the shop.